Well, hello everyone, and welcome to another episode with your girl Audrey Codner from ACCUPLACER tutoring. So, here we are. So today is not really going to be for GED, not going to be for ACCUPLACER. It's actually going to be for those kiddos that's going to be doing SAT and ACT. But there are some components of math that's in here that we all can still take a moment to work on. So if you want to just sit back, relax, and just watch me do math, go right ahead. Supposedly my voice is nice and soothing. Or a little gackle over here and there. We always got something going on. So what we are doing, we're going to be solving rational expressions. So if we refer back to rational expressions, it's just simply fractions that the numerator and denominators are polynomials. That's it. Okay? How we solve it is very similar to how you solving just a regular fraction. A fraction with a fraction, you can probably do cross multiplying, and then you can simplify. But we're going to do a quick little review. So we have 3x minus 6 over 5x minus 2 times x minus 8 over 5x minus 10. So always when you're given a problem, take a look to see what's going on in between. So right now, there's multiplication. So that means if I am going to simplify, I can cross simplify. So whatever's in the numerator, and if it's also in the denominator, they can cancel out because they will give you the equation of 1. So now, let's factor. So I notice the numerator of this 3x minus 6, that can be factored. So if you're like, oh God, Audrey, there's so much stuff going on. All right, well, let me help you out. Let me kind of focus our eye and our attention on one thing at a time. All right, this is something that you can easily do for some of your testing. Get one of those blank piece of papers that they give you, and then all of a sudden you just cover up one and we cover up the other. So now we're focusing our attention on one thing. So we have 3x minus 6. So what they have in common is 3. So I can factor out a 3. And what remains is when I divide the 3 from the 3x as well as this minus 6. So I'm going to have an x minus 6 divided by 3 gives me a 2. All right, so we got that part. So now let's look at its denominator. So I'm going to move this up and focus all my attention on the denominator. So 5x minus 20, they have 5 in common. And it's not 5x because 20 doesn't have an x to it. But what I'm going to do is divide the 5x and that negative 20 with this 5, which gives me x minus 4. Okay, so thank you, Christopher. So now we're going to focus our attention, got stuck in the creek, on the numerator of the next one. This is x minus 8. So that's already factored down. You can't go any further than that. So there's no GCF other than 1, and it doesn't make any sense to do 1 and then a parenthesis. But in the denominator of this one, this we have a factor of 5. So if I divide the original, I will get my x minus 2. Because negative 10 divided by 5 gives me a negative 2. All right? So now we're taking a look. So what we just factored, that's all done. That's done. This is all factored out. And what replaces them are their factored cousins. So now just taking a look, what is it that you notice that's in the numerator as well as in the denominator? Because the numerator, we have 3 times x minus 2 times x minus 8. In the denominator, we have 5 times x minus 4 and 5 times x minus 2. Okay? So, if you notice, they have x minus 2. So x minus 2 in the numerator, x minus 2 in the denominator. If I divide those two things out, they will give me 1. So now, what's happening is we have, not just because they're even numbers, because they're the same expression. So now what's left is 3 times x minus 8 and 5 times 5 x minus 4. And you're probably saying, well, Audrey, oh, there's 2 5s. Couldn't we cancel those 2 out? No. The reason why, if we had a 5 in the numerator and a 5 in the denominator, yes, we can cancel them out. But since both of them are in the denominator together, we can multiply these 2 out. So now, our official answer is going to be 3 x minus 8 over 25 x minus 4. All right, good. All right, so when we're doing these, we're using factoring, we're looking at our multiplication, we're looking at how we can simplify with division, we're doing a whole bunch of stuff. Okay, so we cannot reduce the 8 and the 4 because they're attached to their own expression. In order for them to cancel out, they have to be exactly the same variable, the same operation, and the same number. All right, so this is our answer. So, as I said in the beginning, maybe some people forgot, this is not going to be on the GED. This is not going to be on the ACCUPLACER. It's going to be on SATs and ACTs, okay? So it's definitely going to be on some of those advanced and maybe some people that are currently taking this as a class. So you're definitely going to see those. Now, but if you want to have fun and just watch, you can have fun and watch, okay? I'm not a looker, Audrey. I'm a doer. All right, so this is how we simplified radical expressions. Now, we're going to take a look at solving radical equations. So, as we do that, let me shift. This is what's going to happen. So we have to clear the equations by multiplying each side by the LCD, the least common divisor, or the least common denominator, okay? Once we do that, then we can solve the equation as usual. So this is what I'm talking about. So let me go real slow. So let's take a look at this equation. So if we know about fractions, and maybe this is why a lot of us are like, nope, I'm out, because I used to be the same way. But a lot of things about fractions, we have to have what's called a common denominator. Okay, so rational expressions is going to be a lot about fractions. Okay, so when we do this, we have to make sure that we have the same denominator. In this case, we do. So all we're doing is rewriting the denominator, because that's what they have in common. And we're going to combine our numerator. So it's going to be x minus this whole expression. The reason why I'm putting parentheses around it is because I'm not just subtracting the x. I'm subtracting the x and the 1. Okay? All right? So here we go. So all we're doing is our distributive property. So we basically have x minus 1. What's happening when I do that? What happens? All right. What happens? Yes, thank you, Amy. Because x minus x cancel each other out. And what's left over is -1 over 3y squared. Okay. So since they don't have anything else to reduce, that's your final answer. It's not going to be a positive one because when you subtract, you also subtract the 1. So when we actually change that to a negative x, we also have to change this to a -1. Okay? So we had to do the distributive property. Nope. Negative times a negative is a positive. Okay? A negative times a negative is a positive. So a lot of those foundational pieces is still mixed in with all of these advanced math courses. So that's what I'm saying. Pretty sure you failed. You didn't try yet. Okay? So all we have to do is one, we all need to take a breath. Okay? It's okay. We're going to take a lot of those foundational pieces, knowing what the rules of positive and negative integers are, knowing how to add or subtract fractions are, and then also taking a bit about factoring. All right? So we're taking in those components and we're piecing it together into what's called rational expressions. So I'm still not even with the equation yet. I'm just breaking down the expressions. All right. So let's try another one. Okay, so we're going to take it a little step. So this time we have 4x over 5 plus 3 over 2 equals 3x over 10. Now, I know right away you're looking at it and you're like, nope, I don't know how to do this. I'm too dumb. I'm not going to do this. Stop. All right? We're going to take this step by step. Now, if you're here, I appreciate you being here. If this is too slow for you and you're like, oh, I need advanced stuff, obviously you're new to my little section of the world on TikTok. I like to take components of math and break it down. Not just so you can pass the GED or the ACCUPLACER and so forth. I really want people to feel empowered that they can do math. So I break these things step by step. If this is too slow for you, you can go ahead and scroll on by. I appreciate you stopping by, and that's fine, okay? So if it means I only have 2 people that I'm talking to, I will talk to 2 people, okay? but I really want to break things down, okay? All right, so let me tell you what's going on. Hello, Kelly. All right. Okay, all right, so this, not so much on the GED, but there are components of this that will be on the GED. So if you want to kind of hang out, you can hang out. So if I were to add or subtract fractions, we need to have a common denominator. So let's take a look at our denominator. So we have a 5, we have a 2, and we have a 10. So remember I said that we need the least common denominator. Let me come to the side to tell you what I'm talking about. So we're looking at the 5 times table and the 2 times table as well as the 10 times table. So if I do the 2 times table, whoop, sorry, I got my fan on, it's a little warm. So if I do the 2 times table, we're looking at 2, 4, 6, 8, 10. And I'll go up to 12, all right? If I'm looking at the 5 times table, I'm doing my 5, my 10, 15, 20. And if I do the 10 times table, I got my 10, 20, and I'll go up to 30. Why not? Now, just by this sample, okay, this set of numbers, what is the number that comes up in all 3 of the multiplication tables? Put that in the chat. Okay, so Nicole is saying it's 10. Okay, thank you. Okay, Carissa is saying 10. Good. Is LaSheila saying 10? User, yes, saying 10. Okay, 10. Good, 10. So, keep that in mind. 10, and I know Pog, you said it earlier, so that means my least common divisor will be 10, okay? Keep this in mind. Now we're going back. So it will be great if I can make all of my denominators equal to 10. Now, this one's already 10, so I don't have to mess around with that. Yay, that's a bonus. But I need to change this 5 to a 10, and I need to change that 2 to a 10. Through multiplication, okay, through multiplication, what do I have to, Deanna, good job too, and Paul, what do I have to do to the 5 to make it into a 10? Okay, so Pog is saying 2. Okay, so I need to, good Nicole, multiply by 2. Oh, Beyonce on here, okay. 2. You know, I know Blue Ivy needs a little education. Go ahead, girl. All right, multiply by 2, multiply by 2 times 2, good. So if I multiply this first, the denominator by 2, whatever I do to the denominator, I have to do to the numerator. All right, so now if I want to break down this ratio, I am going to have a denominator that is 10, but my numerator now is going to be 8x. All right, good, Beyonce. All right. All right, both numerator, yes, by 2. Good. All right, don't forget, this is going to be 2 times 5. There we go. I'm going to bring in that plus sign. So now, for the next ratio, I need to change this 2 to a 10. What do I multiply it? There you go. Good. So I multiply this by 5. Thank you, Pog. So that's 5, and that's 5. So whatever I do in the denominator, I have to do in the numerator. So now my denominator for the second ratio is also going to be a 10, But 3 times 5, that gives me 15. All right, good. Good job, ladies and gentlemen. I love it. Good. Now, the equal sign comes down. And since this ratio already has 10, I don't have to do any adjusting. I could just rewrite it. Okay. Yep. So it's whatever the number. So if I look at the multiplication table of 2s, 5s, and 10s, okay, because that was my denominators originally, what number, the lowest number that they all have in common? The lowest number that they have in common was 10. So that was going to be our denominator. Okay. Now, yes, Nicole, this is what we're going to do now. We're going to combine like terms. And this is what happens that's different from fractions. Because fractions, normally, what we will do is we will add up our numerator and put it over the denominator, not for ratios. Ratios, we're doing this so we can eliminate the denominators. And we can focus all our attention on the numerators. And if you notice, that numerator, if I rewrite it, which I will, so we have 8x plus 15 equals 3x. Now we have an equation. And what we're doing is we want to figure out what x equals because we're solving. All right? Yes, Sid, there you go. Yes, you can cancel out all the denominators. Good. All right, so Gary, we're basically trying to take it out of this fraction form and put it as an equals, like put it in as an equation so we can solve for the unknown variable, which is x. Okay, so just follow along with everything. All right, so if we subtract the 3x, there's going to be nothing over here. We always want to balance things out. Okay, I know a lot of us don't want to deal with the negatives, but sometimes we got to deal with that. So when we even this out, we're going to actually subtract the 8x on both sides. You could subtract the 3x, but then you will have to subtract the 15. For me, I'm lazy. I don't like to do too many steps. I know that about myself. So we have 8x minus 8x will give me 0. But I don't need the 0 as a placeholder because I still have this 15 that's on the same side. So now 3x minus 8x will give me what? Okay. You always do the inverse when you're solving, Gary. So if they give you a positive 8x, you have to do the opposite, which is minus 8x. So 3x minus 8x, Amy, Derek, good. You had to multiply the numerator by 10 to cancel out the fraction. Nope, they have to have a common denominator. So you can multiply what you need in order to get it. All right, okay, okay. So I agree with your negative 5x. You have $3. You want to buy something that costs $8. You are $5 short. So now we want to get x by itself. So negative 5x, if you don't see a plus or a minus in between the negative 5 and the x, that means you're dealing with multiplication. The opposite or the inverse of multiplication is division. There you go. Thank you, Derek. So we got dividing both sides by negative 5. So negative 5 divided by negative 5 will give me 1. And since there's an x already there, just bring down the x. Now 15 divided by negative 5 gives me a negative 3. Okay, so our answer is going to be negative 3. So this is saying if I plugged negative 3 back into my original equation, I will get a true statement. Okay, that's the missing piece that's going to make it into a true statement. All right. Okay. So we got plenty of other ones. I'm going to walk you through. Okay, good job, Dallas. Again, no one is keeping you guys here. I mean, it's like, you see math. I'm like, I gotta put a comment to make sure she knows that I don't like math. But yet you stay. Who is the insane one now? You're like, why is this on my FYP? I don't know. But you're here. So you might as well sit down, relax, and let's do some math. You guys crack me up. All right. So let me see if I can find one more similar to that so we can break stuff down. All right. Before I start doing advanced stuff. Let me flip to the other side. All right. So we have, let's see. Okay, we can do this one. We have x over 3 equals 1 over 6 plus x to the 4th. Okay. All right. So, taking a look, think of your multiplications. So some of us, like just winging it, it's got 12. LaCole's got 12. Meat Coffin, multiplied by 12. Got something for you, 12. Pug, 12. Need a lot of help. Okay, just to understand it. And I understand, because it's probably been like a minute since you've seen it, and that's fine. Okay? All right, so this is how everybody's getting 12. So if we look at the 3 times table, we can start at 3, 6, 9, 12. 6 times table, 6, 12. 4 times table, 4, 8, 12. So the least that comes up, the lowest number that comes up in all 3 multiplication was the 12. So we need for these denominators to equal 12. Okay? So now, through multiplication, how do I make this 3 into a 12? Okay. All right. So we multiply by 4. There we go. And whatever you do in the denominator, you're going to do in the numerator. So 4x is just simply that. 4 times x is 4x. Bring down my equal sign. Now we need that 6. So if I got this 6, what do I need to multiply that 6 to make it into a 12? There you go. Good. We got our 2's. Whatever I do in the denominator, I do in the numerator. So that means my numerator here is going to be a 2. Got my plus sign. Now I need to make this 4 into a 12. What do I do to it? Okay, there we go, Gary. Make it into a 3. Whatever I multiply in the denominator, I do in the numerator. All right, so that gives me 3x. All right, beautiful thing. Good, good, nice. Catherine, Bry, good. Is it Gustavo? Okay. Oh, wait, Santi. Sorry, didn't mean to skip you. All right, Nicole, excellent. Now, since we all have the same denominator, and we're doing rational expressions or rational equations, we don't need the denominators. We were using them to figure out what should our numerators be. So we got 4x is equal to 2 plus 3x. Okay, so now we're going to focus on solving. That means we need our x's to be on one side of the equal sign. All right, so Bri is telling me, good, everyone, we got our subtract that 3x on both sides. We always need our x's to be on the equal sign. Think of it, my equal sign is almost like a barrier. Whatever I do on one side, I must do on the other. So 3x minus 3x will give me 0, but I don't need that 0 as a placeholder because I still have that 2. And then 4x minus 3x gives me 1x, and I can simply just write x because a 1 is always understood to be in front of the x. So x equals 2. Okay. All right. So whatever you do on one side, you have to do on the other side. All right. A little yay? Good. All right. You're welcome. Okay. So this is more so like Algebra 2. And if you're taking the SATs or the ACTs, it goes up to Algebra 2. If you by chance a person that's doing English as a second language, ACT is going to be so much better for you. There's so much more verbiage on the SAT, whereas there's more so naked math, as I like to call it. There's more of this naked math in the ACT, like how you learn it in class, versus the SAT, where they do a combinations of things and have you kind of do what's called thinking outside the box. Okay. I do go live every day, at least just once a day. On Fridays, I usually just come at 1 o'clock, but Saturdays I'll be here at 8:30 and also on Sundays at 8:30 p.m. Eastern Standard Time. And then Monday through Thursday, it's 9:30 p.m. Eastern Standard Time because I do a lot of tutoring. All right, so going to take it one step further. Okay, I know you're probably like, okay, just brace with me. One step further. So let's try this one. Okay. So let's just ease our minds into it. I know you're going to be like, what is that, Audrey? Relax. Do not be too tense. Because I know there's a lot of people on here that are like, oh, I know how to do this and then. Congratulations. Again, didn't have to stay. You can move on. All right. Okay. All right. So, Missy, this is the first of me seeing you. So, okay, you missed a little bit on the parts of it. Okay. All right. Do I teach calculus? I do not. But if you're serious about you need someone to help you with calculus, I got a guy. All right. Now, I'm going to walk you through this step by step. Okay? If you want to jump ahead and go crazy, go ahead. But I'm going to break it down step by step. Now, we don't have whole numbers this time. So we can't do the multiplication. But what we can do is, and we have to remember, that this 2x minus 1 is representing a number. So that's like considered all together. Same for this 2x minus 1. That's representing a number. So that's all together. And even this lonely x, that's representing a number. So we can't say, oh, what's missing? They all have, okay, these two are exactly the same, but this one isn't. This one is missing the component or the factor of 2x minus 1. But here's another thing. These two are missing a singular x. Right now that x is with this 2. So my LCD, and I know it's going to look crazy, just follow along. Let's see if I can shift it. There we go. So my LCD in this case, it is going to be that lonely x, and it is going to be that 2x minus 1. Okay. The way that I break it down, and this is just me, just walk through it, breathe. Okay, you just got a contraction. Just breathe. It won't be as strong. It's going to pass it. Okay. We're going to multiply all three of these with something that's missing from this LCD. Okay. So if I go, okay, I can do it that way. If I go to this first one, I already have 2x minus 1. Okay, I already have that. But what's missing is my x. So I need to multiply my denominator by the x in order for it to match my LCD. But here's the thing. Whatever you do in the denominator, you have to do in the numerator. So that means I got to multiply this 2x with this x. Okay. I know there's a lot of letters. Welcome to algebra. This is algebra 2. Okay. So we're going to break it on down step by step. Okay. I know you are in fright or flight. Okay. You're either going to fight or you're going to flee. And I'm proud for the fact that you're here and you're listening. Okay? All right. So, for this ratio, it's going to look like this. X times 2x. Remember, when you're multiplying, you're going to add the exponents. So it gives me 2x squared. Because x times x is the same as saying x squared. Its denominator is going to be exactly what we see. X parenthesis, 2x minus 1. Because eventually, we're not going to be doing a whole heck of a lot with the denominator, all right? We're doing all of this manipulating in order to get the numerators that we want. All right? Now, bring down our plus sign. Oops. Bring that down. Now we're going to work on this middle term. So it just has a singular x. I go to the LCD. Okay. Got my singular x. I go to the LCD. What's missing? Okay. It has the x. But what's missing is that 2x minus 1. So that is what we're going to multiply the numerator and the denominator by. I had to put it like this because I ran out of room. Okay. So my denominator is still going to be my x with my 2x minus 1. Okay? But my numerator, I'm multiplying 2x minus 1 times 1. Anything times 1 is itself. So this is going to give me 2x minus 1. Okay, good. All right. Now, there you go, Gary. Good. All right, we are going to be doing that. The Lilium, okay? So now, bring down the equal sign. Now we're looking at the last one. So we have 2x minus 1. Our LCD is x times 2x minus 1. So you tell me what's missing. Okay. I know, just follow along. Just follow along, because remember, some of you guys are coming in right now and thinking that you can jump in. Good. Good, Cyrus. Good, Gary. Good, Lacole. Good. Is that Saria? Or Saray? Probably messing it all up. Please correct me. Okay. Drede. Good. Safa. Good. Okay. Good. All right. So we are just missing the x. Whatever I multiply in the denominator, I multiply in the numerator. So now I got 1 times x. My numerator is simply going to be an x over, and I could still put it as x times 2x minus 1. Remember, through multiplication, you could change them around and still get the same value. Think about it. 3 times 7, 7 times 3. Both of them are 21. All right? Doesn't matter which way. That's the best thing about multiplication. It can be interchangeable. All right? Okay. In ages. Okay, good. We page it for the second one. Hello, Just Chill. Yes. Now, looking at our denominator, they are exactly the same. Okay? That's what we wanted. And once we do that, we are no longer looking at the denominators. Now we're going to focus all our attention on that numerator. So the numerator, I'm going to rewrite it, is 2x squared plus 2x minus 1 equals x. I know, it looks crazy, but we're doing the right thing. All right, okay. Now I'm going to be truthful, Tiquan. This is not going to be in a GED. This is really to help with SAT and ACTs, okay? But there are some components in here that will help with the GED, okay? All right. What happened to the 2x? What happened to the 2x squared? 2x squared is still there. I brought it down here. Okay. All right. So now, anytime you're doing any kind of solving, so this can go into GED, this can go into ACCUPLACER, this can go into ASVAB, especially when you have to do factoring. That's what's going on right here, okay? So all this stuff before was Algebra 2. Right here is considered Algebra 1, all right? So no, this is not the final answer, okay? We need to figure out what x equals, okay? I just want you guys to see, for those that are usually GED or anything else, this is where you can start paying attention, all right? So now, let me turn that light on for a second. I know, nice and bright, right? So now, anytime your highest degree or your highest exponent When your highest exponent is a 2, that means I am dealing with a quadratic. Quadratics give you that lovely parabola shape or that U shape. Now, because it is a 2, we need to factor. So that means we need this equation to equal 0. The only time a quadratic equation does not equal 0 is when you're doing completing the square. And right now, I want to go with the good old traditional AC method. So that means I need to bring this x over to join its like term with this 2x. So what I do is I'm going to subtract it. In order for me to move from one side of the equal sign to the other, I always have to do the opposite that I see. So it's a positive x, so I have to do the opposite, make it negative. And it's not going to go to the x squared because they're not like terms. It's going to go with the x. So if I combine it, it's going to look like this. 2x squared plus 2 minus 1 gives me 1x, or just x. And then I bring down the minus 1 equals 0. Okay. Yes, true for the t's test as well. Yes. Okay, so we have to make it 0. Okay, so we have to, good, subtract the x on both sides. So now, we're going into factoring. You could do the quadratic formula. That takes an additional more time. Or you can do what's called the AC method. Now, with the AC method, the number that's in front of the x squared, that's representing your a. The number that's in front of your x, that's representing your b. And the constant that is not next to a variable, that's representing your c. So if we can go back to this, what is my a? What represents my b? And what represents, let's see if I can speak, my c. Okay. All right, Queenie, good. Okay. What's going to represent my a? Think about what's supposed to be in front of my x squared. Good, Gary. Hello, Audrey. All right. The boat and the river problems, yeah, they are hard. Yeah. That's when you're doing a lot of trig. So my a is 2. Okay, Chris is saying 1 is my b. Thank you. And what's going to be my c? -1. Also, Nicole saying -1 is going to be my c. Good. All right. Now, this is probably going to be the hardest part. We need to figure out what two numbers multiply together. That's my a and my c. If I multiply my a and my c, I get a -2. Okay, multiply the a and the c. That's why it's called the AC method. Notice there's no plus or minus sign in between the a and the c, so that means you're multiplying your a and your c. 2 times -1 gives me -2. Okay. Now, rewriting my b. My b is 1. So this is the hardest part. What two numbers multiply will give me -2 and add to give me 1. Okay, what two numbers multiplied together will give me a -2 and add together to give me a +1. All right. Yep, you can do completing the square with this as well. All right, so we're saying a positive 2 and a negative 1. Good. Positive 2, negative 1. Good, Chris. Good, Dana. Good, Bond. Good, Rooster. Buster. Good. Okay. All right. That will multiply to get a negative 2. Negative 2. Yes. My bad. Your bad what? Oh, okay. All right. So, because of this information, I like to do what's called set up my ratio. You're like, is this problem ever going to end? It is going to end. I'm just going really slow with it just so you can see the details, okay? Eventually, what happens when you get used to this and you get faster, it'll be so much easier just to get through it. Your numerator is going to be your a value with the variable. Notice it said squares, so I'm going to have 2 of them. So that's 2x and 2x. What goes down in its denominator is the numbers that we found, the 2 and a negative 1. So if you focus on each of these as fractions, this 2x over 2 could be reduced. That could be reduced to 1 over 1. Because they both have 2 in common. 2 divided by 2 gives me 1. Same thing, 2 divided by 2 gives me 1. These 2 fractions are going to represent your parentheses. And remember, it equals 0. So the first parenthesis deals with the first ratio, 1x and a positive 1. So that will be x plus 1. The second fraction or ratio, we don't need to reduce because the only thing that 2 and negative 1 have in common is 1. So the second ratio is 2x minus 1. I was here. Okay. So this is the factored cousin of this. 2x squared plus x minus 1. But remember, it equals 0. So that means we need to figure out what is going to make these two equal 0. And someone said it earlier. Is it Lavo? Here we go. Help me, Lavo. So each of these parentheses can be its own equal. So you have x plus 1 equals 0. And the other one is 2x minus 1 equals 0. Okay, good. Sava, good. Logan, good. Well, Sava, hold on. Part of it is good. Logan, good. I think that's supposed to be equals yes. Lacole, good. Look at you, Lacole. Good job. All right. So I need to subtract 1 on both sides. So x is equal to negative 1. That's one of my answers. If I solve this other one for x, it was a minus 1, so that means I'm going to do the opposite. I'm going to add 1. So now 2x is equal to 1, but I want to know what x is. So 2x means 2 times x, so I do the opposite. I divide both sides by 2. So x is going to equal 1/2. So I knew from the very beginning, when we were up here, that we were supposed to have 2 solutions. Reason why? My highest exponent was a 2. Okay, when your highest exponent, that will tell you how many solutions you should have. If your highest exponent was a 3, that means you should have 3 solutions. Either one of them is a real solution and the other 2 are complex solutions, or you have all 3 of them are real solutions. Okay, your highest exponent will tell you how many solutions you will have. Now, if you want to check for what's called extraneous solutions, you would take your answers, plug it into either the original equation or the modified, and see which one will give you a true statement. So if I plugged in -1, -1 squared will give me 1. 1 times 2 will give me 2. 2 plus -1 will give me 1, and 1 minus 1 will give me 0. So that works. If I wanted to take half, okay, my square root of half is 1/4. 1/4 times 2, that will give me 1/2. 1/2 plus 1/2 will give me 2. Half and a half will give me a whole. And 1 whole minus 1 gives me 0. So that works as well. All right. It's been a decade. Yep. And sometimes, especially if it bounces, that's another one. So that'll give you 2 solutions. But if it was out of 3, like you'll get what's called a double 0 if it's 2. If you just get 1 solution, it can count for 2. And if it's a 3, you could probably have 2 that bounces, but it can't be 2 that bounces and then you get a complex number, because complex numbers always come in pairs. Okay. So we finally ended. You're like, we are finally made it through. Okay. So there are some components. The main thing is, 1, we got to make sure that we have a common denominator. That's the same thing that you see with fractions when you're adding and subtracting them. So you always take a look what's given. Then you basically, all right, what's missing? This is missing a 2x minus 1. These 2 are missing an x. You place them so you can have a common denominator. Once you have a common denominator, you don't need the denominator. Then your focus is going to be solely on the numerator. So then, once we got here, my highest degree was a 2. So that tells me, okay, I got to do some factoring. So that means let it equal to 0. Unless you're doing completing the square, that means you would have to subtract the x and then add the 1 if you're going to do completing the square. Because completing the square, that's the only quadratic formula that does not have to equal 0. It equals the constant. And what a constant is the number that does not have a variable associated with it. Then you can choose any method you want. You could choose AC method, kind of like doing it. You can do quadratic formula. Like I said, you can do completing the square to find out what your 2 factors are. Then set those 2 bad boys equal to 0 to find out what your value of x will equal. Okay. Okay. Yeah, you're going to have to watch the replay, Nixon. Because I just redid the whole thing. Okay. Well, I don't know why, Gary. Because I just feel like a lot of people are just like, all right, this is it. There you go. There. All right, enjoy. No one's not going to take the time like, are you getting this part? No one does. Not too many people do that anymore. All right. So that is our magical time. So if anything, if you like the setup of my notebook, I actually created this. Yep, this is my math notebook. And I am working on getting self-published. I'll be self-published this weekend. I'm so excited. Okay, so it's 100 pages, just like this, where you can have your formulas on one side, your steps on the other side, and as well, if you struggle with multiplying, I got you. If you struggle with getting factors, I got you. All right? In the very back, I have factor sheets. Most time you'll see your factors of anything. This goes up to 1 to 100, but mine goes up to 1 to 200 because this book is really supposed to be designed for people taking Algebra 1 and up. A lot of the notebooks that we see nowadays is really geared towards elementary school people or just journaling, okay? This is really directed to my advanced students. So if you struggle with knowing the rules of integers, adding, subtracting, multiplying, dividing, I got the rules plus the knowing the rules of integers, adding, subtracting, multiplying, dividing, I got the rules plus the example. Sorry. Okay, let's see if everybody's here. Okay, sorry about that. Phone call. So we have our adding, subtracting, multiplying, dividing, equals, inequalities. So these are the most popular words that are used in most word problems. As well as, hey, we got our linear and our quadratics. That looks familiar, standard form. Then this was the quadratic formula. And then you have your discriminants and all that. As well as your order of operations. So we're looking at from the US side and also to the international side. The properties of exponents. I think someone asked me why x times x equaled x squared. Because when you have the same base, you're adding the exponents. So x to the first power times x to the first power, 1 plus 1 gives me 2. So that is the properties of that law of products. Then we also have like properties of quadrilaterals, looking at the transformation, a little bit of geometry. Then we got our areas and perimeters. Sometimes we forget how to do, especially the trapezoid. A lot of people have a tendency to forget that one. Then we have volume, surface area, area of the sector, arc length, equation of the circle, which I'm going to be doing a little bit more, and the unit circle, as well as SOHCAHTOA and Pythagorean theorem and some of the identities and sine and cosine, especially if you're going into pre-calc or above. Okay, pre-calc or trig, you're going to see those as well. And then I also like to give a little brain break. Sometimes we just need something, we can't have our phone out, so there's a couple pages of brain breaks in there. So this is my math notebook. I'll actually show you like the different covers. Okay, so this is one cover, then we just finished with this is the other cover, and then this is the other cover. So we have 3 different covers, but same information. So we have all of these lovely notes that I've been using and been doing since the beginning of February. Yep. So these were like all the notes that I've been doing. Now, if you just want to get copies of my notes, I'm actually selling those. They're called Audrey's notes. I know, really inventive. And with Audrey's notes, let me pull this aside. And this is what I'm excited. That's going to be out. And actually, the book is actually going to be out. So you don't have to worry about digital copies and you making your own copies. All right. So with Audrey's notes, it's coming. This is a temperate. You get copies of my exact notes. Now, if you notice, everything is in there. And with each of the notes, a lot of them have a QR code. So if you scan this QR code, it will take you directly to the TikTok live that I did that is with the explanation of these notes. So you don't have to go like, oh, it's great to have the notes. I wish she could explain it to me. So because I don't live in your house or sometimes even your own time zone, you can actually scan it and go straight to that particular lesson. So I decided to put it all into a book so it's easy for you guys to get it. And right now we've completed book 3. We are currently on book 4, but book 3 is up for purchase. I will be sharing the link of that as soon as it's officially posted, so you don't have to worry about Amazon anymore, because I know a lot of you guys do not like Amazon and all the shenanigans that's going on. So you can actually order the books through there. Okay, you need it for teas? Yes, definitely this. Yes. How do we order one or get them? All right, so right now, the digital copies are on my website, but as I said, if you can just hold on for one more day, you'll be able to order the actual book. Nice little soft cover. Manageable. Like I'm pinching covers here. All right, and same thing, nice printed coloring, so you'll be able to get your own books. And then it holds like 100 pages. I know I write large, and yes, some people said, we're supposed to do math in pencil. Yeah, I would love to do math in pencil, but you can't bloody see it. So that's why I have to risk and be scandalous by doing it in pen. But there's also something called erasable pens now. Get up to the modern date, people. All right. So I want 1 through 4. Okay, well, we're currently just starting 4. So it's going to be a bit, but at least you can get 1 through 3 in the meantime. Okay? You get 1 through 3. And the way that, since I cover sometimes 1 or 2 concepts a day during my sessions, yeah, you might be able to get this probably, I want to say, close to the end of next month. Now, here's the thing. Here's a couple stuff. If you want to get the replays right here, right now, you're like, I don't want to wait. You can subscribe to my YouTube channel. On my YouTube channel, I have a playlist that takes all of my TikTok lives. Okay? All of them since February the 5th. That's when I've been starting doing it. There might be some that might be missing because I forgot about TikTok only holds it for 30 days, but here we are, all right? So if you want to go to Audrey Codner ACG Math Tutoring, you can go there and just peruse to your heart's content, okay? And then this is my live schedule. So again, Saturday and Sunday, I'm here at 8:30 p.m., Monday through Thursday, 9:30 p.m., and 1 o'clock on Fridays. Now, if you want to get any private tutoring, I have that available. I still have a couple of slots left because a lot of my seniors are graduating, part of my first groups. But then also, like I said, the math notebooks, they will be on called Books by Audrey Codner, which is awesome. Can't wait. But if you want some on-demand courses to help you step by step with the GED, the ASVAB, even with Algebra or the ACCUPLACER, I do have courses and all that available on my website, which is accmathtutoring.com. You can actually just click my picture and then go to my profile, and the link is there. In addition, and then I'll be done, a couple other people for you to follow. I noticed some people said tease. So if you need helping, if you're going to go into nursing and you need help with your understanding your dosage calculations, if you follow a blessed RN, she is awesome. I know she goes on. She might be on tonight or she might be on later on. Right now, if you leave me, go to Impact Math 19 just to see if Miss Taylor is available. She does the TEAS test, the ASVAB, and the GED. If you need a chemistry tutor, you can try Professor TK. If you want to learn a cool way to add, subtract, multiply, or divide math, you can follow my friend Learning with Lynette. She does learning with the abacus. It's so cool. Like after you do this, it just really helps with your brain function as well as help you learning math. So if you got a younger niece, nephew, maybe even yourself, and you want to teach your kids how to do adding, subtracting, definitely follow her as well. Now, if you do have any younger ones that needs help with their reading and with math, my friend Nancy is actually doing a math lab this summer, and she does pre-K to kindergarten homeschool curriculum. So if you have some younger ones that need some homeschooling, maybe a help with a curriculum and breaking stuff down, definitely follow my girl Nancy. She's a new add-on, okay? Yes, with word problems. Okay, definitely. So if you guys have any questions whatsoever, also be on the lookout for me. I will be teaching a live summer course, and I am starting from the very beginning. So we're talking fractions, decimals, solving one-step, two-step, multi-step equations, also dealing with the algebra, like how to solve, how to graph, what is slope, how to find the equation of the line when you're given a point and all that. So the very basis to build you up, because I noticed there was a lot of people that are coming onto my lives that are currently taking community college classes. And the first thing they say is the class is way too fast. And I'm like, hey, of course, please do that. So if anything, let's go ahead and just spend some time during the summer and break these concepts down. Okay, so be on the lookout in the next week. I'm going to be announcing that fully to everyone and how to register, and we're just going to get ourselves started. I'm looking at the beginning of June because I know 4th of July weekend, everybody wants to take off, and then the week before school starts back up, everybody wants to take off again. So it will bleed in a little bit with August. We'll just change our times. I'm looking at mostly the evening hours for that. So it might be occurring either before, probably not after my lives, but maybe possibly before my lives. And my lives, like say, during the week is at 9:30 at night. So we're looking at roughly like around 8. So I can get as many people from all parts of the world to join in. Okay? So there we go. So that's good. Thank you. Thank you so much. So I'm looking at the summer course starting like early June. I was thinking about June 1st, but then I'm like, wait, people got graduations that week, and I know that's going to be a bit tough for people. So it might be like in the middle of June, just before the kids are about to get out of school for us in Maryland, and then just take it on to August. So basically, I want to get you ready for the fall if you're thinking about going to community college or getting your GED, because realistically, you can't learn a whole year of algebra in like 2 weeks or 5 weeks. You know, you're going to need some time. Okay? All right. All right. Thank you so much, guys. Oh, look at this. 20K? What? All right. So if you have any questions, if you're currently in the class and you're trying to get your finals situated, statistics is not my jam, but I do know some people who it is. Calculus is not my jam. Pre-calc, yes. Not that AP pre-calc. Pre-calc, definitely yes. But if you need some assistance, if I can't help you, I know some awesome people who can. So please don't hesitate. If it's something that you need to know, please ask. Okay? That's the only way I can help. All right? As this is how I want to help you. All right? You guys are helping me with all this love that you're giving and the time and attention, because you could have easily left a long time ago. All right. 22, I'm good with, guys. I love the taps. I appreciate it. These little jobbers are cracking me up. Is that like highlighters? That's cute. Okay. All right. So if anything, I will see you guys on the flip side. I will see you tomorrow evening at 8:30. But if you have any questions, also be on the lookout for the big announcement of my new bookstore is live and ready to receive. That should be coming out tomorrow. All right. All right. Can you do complete and square next time? I can do complete the square next time. I can definitely do that. All right. Well, thank you so much for the love and attention, and thank you for the idea, because sometimes I run out of ideas. I can't remember what you guys want to know, what you guys don't want to know. All right, so I definitely could do complete the square, and then we could, just jump around like we normally do. All right, guys, have a lovely day. Take care. Bye now, and continue being awesome. I appreciate you.